We have an 8-meter-long beam. A uniform distributed load of 10 kilonewtons per meter sits between point C and D. First, we calculate the support reactions. Taking moments about point B gives us an upward reaction of 12.5 kilonewtons at A and 7.5 kilonewtons at B. To use Macaulay's method, the uniform load must extend to the right end of the beam. We artificially extend the downward load in red and balance it with an equal upward load in blue. This clever trick allows us to write a single continuous bending moment equation for the entire beam. Integrating the moment equation once gives us the slope equation with a constant C1. Integrating a second time yields the deflection equation and constant C2. We find these constants using boundary conditions. The deflection is 0 at both supports, which tells us C2 is 0 and C1 is negative 79.167. Before calculating the final values, we compute the flexural rigidity, EI, which is 24,000. Plugging x equals 0 into the slope equation gives a slope of negative 0.0033 radians at A. Setting x to 4 meters gives a downward midspan deflection of 7.92 millimeters.